Hey folks, it's Wednesday, January 6th. I will be rejoining you tomorrow. Today we're on to lesson 69, which is a topic called Integration by Parts. I remind you, you have a quiz tomorrow. It should be on derivatives and integrals. Unless something has changed, you can ask Mrs. K if there's been a change, if you so desire. All right, if I gave you an integral and I said integrate this definite integral, you would use a shortcut rule. You've memorized many. If that failed, you would assume that you could use something like U substitution. Okay. And there were qualifications for U substitution. Do you remember the qualifications? You had to have an integral of something like this. You had to have a composite function in the integrand, and then the inner function, its derivative, had to also be in the integrand on some scaled version. So this will qualify for, say, U substitution. But there is the rare exception where neither of these work. And in AB, the only option left for you in Saxon is something called integration by parts. Integration by parts. All right. Integration by parts follows the following formula or structure. It goes like this. The definite integral of U dv is equal to U v minus the integral of v du. Let me make the v's black since my v's and u's are not easy to tell apart. Everything else is in red. Got it? Definite integral or indefinite integral of u dv equals uv minus indefinite integral of v du. Like when would you ever use such a thing? Okay. Well, if you have some integral that you can't use a shortcut rule on, you can't use U substitution on, and you're like integration by parts, my only option left, you take whatever they give you and you make it fit into this structure. And you do some algebra or calculus, whatever it's going to be. And from there, you should be able to easily rewrite it this way. And while you couldn't solve this integral, you can easily solve this integral. And so you can actually integrate. Let me show you what I mean. All right, so here's the formula up top again, and we're going to attempt this problem right here. We're given the indefinite integral of x e to the 2x dx, and we're asked to integrate. Well, no shortcut rule. Also, integration by U substitution fails, because while we do have a composite function in e to the 2x, the derivative of 2x is no way x, right? It's 2. So we're left with integration by parts. So what's our strategy? Step one, you need to take this integral and make sure you're looking at it as this. You're like, what do you mean? Well, let me rewrite it with the colors. We're going to say u is the same as x. And we're going to say that dv is the same as e to the 2x dx. I'll write that off to the side here, right? We're going to say that u is equal to x. And we're going to say that dv is equal to e to the 2x dx. All right. Now that we've done that, we somehow need to get over to this side. And it'll be easy once we do a little bit of calculus, just a little bit of derivative, a little bit of integral. Watch this. I have u. So I've got this u. I also have dv. Right? So I have this guy right here. But I'm missing three key ingredients here. V, or two more key ingredients, V and du. So how am I gonna get them? Well, watch. I can get du from u equals e to the x. I'm just gonna ddx both sides, okay? And I get du dx equals what? 1. Therefore, du equals dx. There you go. I just got du. I just got this guy right here, du, which I needed. Now from here, I can actually integrate. I'll just rewrite this, dv equals e to the 2x dx as dv dx equals e to the 2x. All I did was bring the dx to the other side. And now I can integrate, right? I got a derivative function, I can integrate it. What's the antiderivative of dv dx? V. And what will v equal here? 1/2 e to the 2x. Right, if you took the derivative of 1/2 e to the 2x, you'd get e to the 2x. All right, so there is v, which you needed here and you needed here. Now you have all the components you need. You have you have v, you have v again, and then you have du. So you can rewrite this guy as this guy. So let's do that. All right. Equals, we're down here now. We've done all the hard work. Now we just got to kind of fill in the blanks here. X e to the 2x dx, which is like u dv. We're going to rewrite it now as uv minus v du. Let's do it. Okay, so what did we say u was? We said u was x. Okay, so here's x. What did we say v was? We said v was this guy right here. 1/2 e to the 2x. Okay, and then what's the next symbol we write? Minus the indefinite integral of, back to v, which is again right here. That's 1/2 e to the 2x. And then the final ingredient that we need is du, and du is where? Right down here. Okay, so that's dx. All right. You need to see this. We started with just an ordinary looking integral we can't do by u substitution, so we know it's integration by parts. We have to rewrite this so that it kind of fits this format right here. Indefinite integral of u dv, and that's what we did right here. The next thing we need to do is translate that to what it's equivalent to, because this will be solvable right here. uv minus indefinite integral of v du. But it's not quite that easy, because while we have u and we have dv, once we pick them, we still have to differentiate to get what du is and integrate to get what v is. But once we have those ingredients, we just plug and chug. So let's do that, right? We did it already. Now all we have to do is rewrite this thing. This is 1/2 x e to the 2x minus, now we anti-differentiate, what is that, 1/4 e to the 2x plus c. Let's see, 1/4 e to the 2x would be 1/2 e to the 2x, that's right, plus c. You can never forget the plus c on there. So you go. What are we doing? Given this integral right here, which we cannot solve by shortcut rule and we cannot solve by u substitution, that we have to solve using integration by parts, we kind of go through this long algorithmic process, which now allows us to actually get the antiderivative function that we couldn't get any other way. That's integration by parts. Now let's try another example here. What if I give you natural log of x dx? Okay, looks super easy. You think there's probably a shortcut rule for that, but there isn't. we're not asking you to differentiate, we're going to anti-differentiate, right? If I had given you alternatively this problem, you'd say, oh, I know the antiderivative of that, no problem. It's natural log of absolute value of x plus c, but that's not the problem. It's this. You don't have a shortcut rule for it. Certainly, U substitution won't work for it. So you're stuck with integration by parts. Let's see what we can do with that. Do you remember the formula for integration by parts? We have to follow this structure. Definite integral of U dv is equal to U v minus the integral of v du. If you're trying to remember what this is, well, I hate to say this because it sounds weird, but it sticks in everybody's brain. If you're trying to remember the order of letters here, at least on the right-hand side, it's ultra, violet, voodoo. I know, weird, but it's UV, VDU, ultraviolet, voodoo, and the other side is UDV. Okay, so you use that, ignore it, it's up to you. Let's go. Got to rewrite this thing. Well, maybe we say U is natural log of x. In which case we're saying dv is what? What's the only thing left in this integrand? And in the whole space that's being summed up, dx. So what are we saying again? We're saying that u is equal to the natural log of x, and we're saying that dv is dx. You see how I used every part? Except for the summation sign, I used every part there. Okay, great. So what's the next thing to do? A little bit of calculus, a derivative, and an integral. Let's differentiate here with respect to x. We get du dx is equal to what? 1 over x. And we're trying to get du by itself, so du is equal to what? I can even do it in red so you can see what I'm getting. Du is equal to dx over x. All right, and on the blue side over here, dv equals dx is the same as what? dv dx equals 1. Anti-differentiate, what do you get when you differentiate dv dx? V. And what do you get when you differentiate 1 with respect to x? X. Here, I'll rewrite it. V is equal to x. We have our 4 ingredients. Let me highlight them for you. 1 ingredient u, 2nd ingredient dv, 3rd ingredient du, 4th ingredient v. We have everything we need. We already have the original function right here, the original function written as the left-hand side. Now, what we need to do is rewrite it as the right-hand side. Okay, so this is going to equal. Okay, let me just make sure you know where I'm at right now. And I'm going to rewrite. Here, I'll bring this down so you can see it. The natural log of, the integral of natural log of x dx. So all I did was slide this down. All right? And now I'm going to write it again, equals definite integral of, this is uv minus definite integral, indefinite integral of v du. What's u? U is natural log x. Okay, what is v here? V is x. Sorry, u, natural log of x times x. That's uv. Minus the definite integral of v, was v again, x. And then du was dx over x. And this might look like a mess to you, but look again. That's going to equal x natural log of x minus the definite integral of just dx, or 1 dx. And that means x natural log of x. What's the antiderivative of 1 dx? X. So x natural log x minus x plus what? Plus c. There you go. All right, one more problem for good measure. Number 3, definite integral of x natural log of x dx. Do you remember the formula? U dv equals what? U v minus the integral of v du. Okay, so we got to rewrite this guy. Let's rewrite in definite integral. Place a u, you'd think it would be x, and you'd think dv be natural log x dx, but you'll find that will not work. So I'm going to go with natural log of x for u, and I'm going to go with x dx for v. I think that's going to work. Not positive, but I think it will. All right. And then that's going to equal these things over here. So let's write all these terms. I'm going to write them down at the bottom here. Okay. I just said that u is equal to what? Natural log of x. And I just said that dv is equal to x dx. So we differentiate with respect to x, and we get du dx equals 1 over x, which is the same as du is equal to dx over x. That's legit. That's those two ingredients. Here's the third ingredient. Now we just need to integrate on this side. So bring the dx to the other side. You get dv dx equals x. Anti-differentiate that, and you get v equals 1/2 x squared. Okay, we successfully got a bunch of ingredients here. Let's see if they're useful. All right, in place of u, I need natural log of x. In place of v, I need x dx. No, sorry, excuse me. Let me erase that. I'm a little tired here. In place of v, I need 1/2 x squared. Okay, we got minus the integral. V again is 1/2 x squared. And du is dx over x. Let's see if this thing pans out. I suspect it will. So we got 1/2 x squared natural log of x minus integral of 1/2 x dx. Yes, we can handle this one, no problem. So the same as 1/2 x squared natural log of x minus, what was that, 1/4 x squared? Yes, that is. Plus c. Done. All right, so this is how you do integration by parts. You are given a function, an indefinite integral. You can't solve it by shortcut rules. You can't solve it by use substitution. You got to use integration by parts. You have to assign, the integrand, the integral sign is the integral sign, but the rest of it you have to assign. So I had to assign x natural log of dx somewhere into u dv, and I assigned it this way. If I had assigned it the other way around, it wouldn't have worked. After I do some work to get all 4 ingredients, I rewrite as uv minus integral of v to u, and then boom, got my answer. Don't forget my plus c. All right, folks, you know what you're doing now. You are working on lesson 69. That was about 20 minutes. You should have a good 30 minutes to be working. You're working diligently on this. If not, you're moving on to the next lesson if you're done. but you are definitely grilling your calculus in preparation for that 5 on the AP exam. You can do it. I'll see you tomorrow. Bye.